Hello everyone. So in the last video we saw how to debug a C program using the LLDB debugger, and this was the program that we were debugging in the last session. I wanted to touch on two topics in this video. One on how to debug programs written in other languages using LLDB, and on watchpoints. So I want to show you, for example, how to debug a program written in the Zig programming language. Zig is a slightly better version of Zig. No, actually not slightly, it's a much better version of Zig, and it's a relatively new language, but we can use some of the standards such as dwarf to debug programs written in Zig using LLDB. So let me compile this program first. So I say zig bldxe mm.zig. You can execute it like this. Works. So let me load it up using LLDB. So I do a breakpoint first on the main function, branch main. It says 2 locations. Run. There seems to be some function which comes from elsewhere. Let's take a look at it later in subsequent videos, but for now let's focus on the example. So I say continue, and you can see that it stops at our main function. So frame variable shows you the value of the variables in the program. I can do the same things that I did in the C based executable. I can say thread step over. It steps through each of the lines of code. And say frame variable. You can see that shows the value of the bits, which is like a new variable that we initialize here. And I say thread step over, step over, step over, frame variable. You can see that we add also like new variables and stuff. So yes, so this works for Zig. Now let me try to like debug some program that I wrote in C, and I'm trying to get it to work with JavaScript. So you can write plugins for Node.js in C. I will show you some of the sample code that I've been working on. So this is some C code which uses the Node API to bind C plugins with the JavaScript. Node, let's say console.log. And I can use LLDB to debug this as well. There's my file called lib-bindings.js, which loads up my native plugin and exposes it to JavaScript. Let's see if we can debug this as well using LLDB. So LLDB file node, lib-bindings.js. So the way this works with native plugins is your native plugin gets compiled into a dynamic library, and when you try to import your native plugin, it loads the dynamic library, and then JavaScript knows how to call into like native plugins based on the API. Let's not get too deep into it. I want to make and like cover this in like separate videos to show you how this might possibly work. For now, let's just have like an idea of like, okay, this is the possibilities that you can do with LLDB. So I set a breakpoint in DL open, and I say thread let's continue. Let's continue. No, sorry, run, because we haven't started the program yet. So it stops at our breakpoint, which is DL open, and let me do thread step out. So what step out does is it finishes, it continues executing DL open, and at the point where DL open returns, it returns and stops. So thread step out, we can see that it stops after executing DL open. I have a let's not get it too deep into the C plugin thing, but like I have a native function called ggmo tensor1d, which is part of my plugin, and I want to set a breakpoint at this. And after the DL open finishes executing, like your native functions get loaded into the Node.js runtime. So Node knows that, okay, like this is a function, your LLDB knows, okay, this function is actually present in my memory, and I can set a breakpoint there. So I say continue. Right, and you can see that it stops at this function ggmo3d and 1d, and I can say thread backtrace. And this is the trace of how we got to this function. So we see like a lot of node related stuff here, which frankly, to be honest, like I don't know, and it's also like not important at this point, but I can continue, and the program exits. So now we do exit, and we're back to our show. So the next part of the video that I want to cover is basically what is called as a watch point. Watch point is, think of it as a breakpoint, but we can control a little bit on how the breakpoint behaves. So let me load this up, debugger, and I say branch on run a pointless loop. Say continue run because we haven't started the program yet. Frame variable I. So we have the value of I. So a watch point lets you stop the program when a certain memory location is being read or written to. So for example, I want to say here, stop the program when the value of I hits 5. If I set a breakpoint on this line, this breakpoint will get triggered on like every loop iteration, which we don't want. We just want to know, okay, who is setting the value of this variable, or let me know if the value of this variable changes so that I can debug on how the change happens. So I can do watch point set variable I. So this sets a watch point on the variable I, but I don't want the, if I try to do continue, it's going to stop on every iteration of the watch point. So frame variable I, if I say continue, I is 1, you can see that on every iteration it stops. What I want to do is basically say something like watch point modify, if in condition I is 5 on this watch point, and it modifies the watch point, and we say continue and it stops. Say frame variable, now I is 5. So you can see that it skipped a few iterations and it only hit it when the value of I is 5, just like how we set it here. So this is an interesting feature that you can use if, for example, that you have a variable, like a global variable that seems to be getting modified from some function, but you're not sure. So you can just set a watch point on the variable directly and stop only when it's changed. And you can look at a thread backtrace, for example, to see which function might have potentially changed it. We just have like, this is a local variable that's inside a function, and this is the only function that has access to the variable. So here we're not bothered, this is just an example, but you can see how it can be useful. So let me do continue, and we've exited the program. So that's it in this video. I just wanted to show you how we can debug programs written not only in C but other languages as well, and on watch points. In subsequent videos, we will see more features about the LLDB debugger, such as how to debug threads and how you can inspect the actual executable image that's loaded into memory. Thank you for watching, and have